In this video, I'll go over how to do the classwork problems. And the classwork problems are very similar to the homework problems. So when I do number 1, follow along and then try number 10. And you can check your answers. The answers are uploaded on the PDF of this work that's about to be done. So it says write an equivalent expression. For number 1, we have 4 to the x plus 3. So anytime you have an exponent that has a plus or minus in it, that means that the base was multiplied. So we have 4 to the x times 4 to the 3. When I have the same base and I'm multiplying and they have different exponents, you add the exponents. So we're going backwards from that. Anytime you have a base raised to an exponent and the exponent and the base are both numbers, not variables, that's a number. This is the same as 4 times 4 times 4, which is equal to 64. So this is equal to 64, and so this becomes 4 to the x times 64, but we always put the number in front of the base with the exponent, the variable part, so this equals 64 times 4 raised to the x. Number 2, we have 5 times 9 raised to the y, 9 raised to the y minus 3, times 3 raised to the y. Now we have two different bases raised to powers, and when I'm using exponents, it's always easiest to get a common base. So I'm going to rewrite 9 as 3 squared. So 9 is 3 squared, and outside of the parentheses is still the y minus 3. We still have a 5 in front, and then we're going to multiply that by 3 raised to the y. Now we know from exponent rules that if I have an exponent inside the parentheses and then raised to another exponent, that exponent, these get multiplied. So we have 3 raised to the 2 times y minus 3 times 3 raised to the y, and we still have our 5 out front. Right? So I can put parentheses around that just to keep it sort of clean for you as you're learning. Now this 2 gets distributed in. 3 raised to the 2y minus 6, so we have 5 times 3 raised to the 2y minus 6 times 3 raised to the y. And now I have a common base, different exponents, so I'm going to add the exponents since it's multiply. So that's going to equal, I'll keep going down, 5 times the base 3 times the exponent 2y minus 6 plus y. 2y plus y is 3y, so I get 5 times 3 to the 3y minus 6. Now this part of the exponent, this minus 6 part, is the same as if I rewrote this as 5 times 3 raised to the 3y times 3 raised to the negative 6. But we know negative 6 means 1 over 6, 1 over 3 raised to the 6. So we have 5 times 3 raised to the 3y divided by 3 to the 6th. And that's a good enough answer. But since it's 3 raised to the 6, we know that this part here is 3 times 3 times 3 times 3 times 3 times 3. It's a number. And so we can write that one as 5 times 3 to the 3y over 729. And these two, in my opinion, those are equally simplified. Okay, next one, number 3. And I'll do it over here. We have 6 raised to the 2b plus 36 raised to the b. I'm looking for a common base. I'm adding these. I'm not multiplying. And so when we're adding them, we're looking for a common base, and then we're going to treat it like an algebra expression where the base is the variable. And so we have 6 raised to the 2b plus 36 is 6 squared raised to the b. And so we have 6 raised to the 2b plus 6 raised to the 2b. And so this 6 to the 2b, that's like having an x. I have something plus itself. That means I have 2 of those. So I have 2 times 6 raised to the 2b. Next one, 4. We have 16 to the x minus 2 times 2 to the 4x plus 3 times 4 to the 2x. We're looking for a common base, and so I know 16 is a power of 2, so I'm going to replace 16 with 2 to the 4th, because 16 is 2 times 2 times 2 times 2. So 16 is 2 to the 4th, and that's raised to the x, minus 2 times 2 to the 4x. So I can see this coming, that I have a 2 to the 4x is going to be my common piece here. And I have 3 times, and now 4 is 2 squared. So I'm going to rewrite 4 as 2 squared, and that's raised to the 2x. So this first one, 2 to the 4th raised to the x. When I raise a power to a power, I multiply, so I have 2 to the 4x. Minus 2 times 2 to the 4x. Plus 3 times 2 squared to the 2x, so I multiply those powers, 2 to the 4x. So what I can imagine is this is 1 times 2 to the 4x. And therefore we have 1 times 2 to the 4x minus 2 times 2 to the 4x plus 3 times 2 to the 4x. So let's just think about this in slightly different way. If 2 to the 4x, if I just called this like y, right? These would all be y's. If y was equal to 2 to the 4x, I would have 1y minus 2y plus 3y. Well, you know how to do that. It's 1 minus 2 is minus 1 plus 3 comes out to be 2. And so we have 2, and then instead of it being y, it's times 2 to the 4x. And that's your answer, 2 times 2 to the 4x. So anytime you have the same base raised to a power, it's like a variable there. So you have 1 of those minus 2 of those plus 3 of those gives you 2 times 2 to the 4x. Okay, I'll continue on with the 5 through 8 in the next video. But what you should do now is you should try 10 through 13 using these same techniques.